Welcome to TJ's Maths Clinic. In today's presentation, we continue with our solutions to sequence and series. With us here is subtopic word problems on arithmetic progression and GP. How can we apply this sequence and series to real life situation? How can we use this topic called sequence and series to solve a real life problem? With us here is example 1. Let's look at how we can apply it. This is applied mathematics. Let's look at it together. The houses on the side of a particular street, I assign odd numbers. I what? Assign odd numbers starting from 11. If the sum of the numbers is 551, how many houses are there? It means how many houses are there in that street. You see the real application now? We want to look at how many houses, given that we are using odd number to number those houses on that street. Let's look at how we can look at it together. First thing to do, let's write down the solution and try to interpret the question. Odd numbers, 11. Odd numbers are numbers that when you divide it by 2, there will be remainder. And the numbers of those houses will start from 11. So we have 11, comma, after 11, what's the next odd number? Of course, it will be 13. After 13 is what? 15. After 15, 17. In that order. So let's look at the behavior of these numbers. Which type of sequence is this? From 11 to 13, from 13 to 15, from 15 to 17 is increasing by what? By 2. So it means the common difference is 2. So meaning this is arithmetic progression. Very important. So since this is arithmetic progression, our first term, of course, will be 11. The common difference D, nothing but T2, this is T2, T1, third term, and this is fourth term. To find the common difference is either T2 minus T1 or T3 minus T2 or T4 minus T3. That will be 13 minus 11, that will be 2. From the question, if the sum of the numbers of the houses now, the sum is given as 551. We are asked to find how many houses are there. It means we are looking for the number of terms, which is the same as the number of houses on that street. So n, which is the number of terms now, is not given. Very important. Sum of arithmetic progression, when the last term is not given, is given as sum, which will be equals to n divided by 2 multiplied by 2a plus n minus 1 times the common difference d. Let's substitute. Sum now is 551 will now be equals to n, that's what we are looking for, divided by 2. A is 2, is 11. 2 times 11 is 22. That will be 22 plus n minus 1. The common difference is 2. So we have 2, we close the bracket. Let's simplify at this point. We have 551 will now be equals to n divided by 2. This will be 22. This 2 will distribute 2 times n. That will be plus 2n. 2 times minus 1, that will be minus 2. So at this point, we can cross multiply. We are almost there. We are looking for n. So we can remove the question. Now, let's remove the question. How many numbers are there? That's how many numbers are there on the street now. So, next thing to do, let's cross multiply. 551 multiplied by 2, that will be 1102, will be equals to this n now. N will distribute over 22 plus, before we do that, 22 minus 2, that will be 20. So let me write 20 here plus, because 22 minus 2 is 20 plus what? 2n. So at this point here, we can clear the bracket. 1102 will be equals to n times 20, that's 20n. I hope we are together. Plus 2 times 2n, n times 2n, that will be 2n squared. Of course, this is quadratic. So let's rearrange, because quadratic equation is of the form ax squared plus bx plus c equals to 0, given that a cannot be equals to 0. So let's rearrange this. We have 2n squared plus 20n. This is plus 1102 it will, when you crosses this equal sign, it will be 1000 minus 1002. Okay, hope we're together. So the next thing to do is to see how we can factorize this. We can equate this to 0 rather. Let's equate this to 0, okay, and see what we can do. Can we factorize this? Yes. Before we do the factorization, can we reduce this? Yes. Let's divide 2 by 2 and see. 2 is a factor, so we can reduce this. We'll have n squared plus 2n divided by 2, that will be 10n, minus 1102 divided by, that will be 551, will be equals to 0. Two factors of 551 such that when we multiply it, we get 551, and when we add, we get 10n. That will be 29. Yes, that will be 29 plus 29 and minus 19n. So it will be n squared plus 29n minus 19n minus 551 will be equals to 0. Very important, okay? So we can group this. Let's group this and factor out. Let's group this and factor out. Let's move here and see what we can do, okay? Next thing to do, let's factor out. What is common here is n. That will be n into n plus 29, close the bracket. What is common here, of course, is minus 19 into n plus what? 29. Clearly, if we clear this bracket, we'll still get this. So what we have inside the bracket are the same. Let's pick what we have outside. That will be n minus 19. Now close the bracket. Then n plus 29 will be equals to 0. Equals to 0 means either n minus 19 is equals to 0, or n plus 29 is equals to 0. Let's bring this minus 19 here. We'll have n as 19, or n, let's bring this plus 29 to the other side. That will be minus 29. So n is 19 or n is minus 29. And remember, the number of houses cannot be negative. So since we conclude now, since n cannot be what? Since n cannot be negative, therefore n is equals to what? 19. We'll pick the positive n now, which is 19. It means how many houses are there? There are 19 houses in that street. 19 houses. So that will be the solution to this question. There are 19 houses in that particular street. You see the real application? Very interesting. Thank you for watching. Please do share this to your learning colleagues. And don't forget to subscribe to TJ's Maths Clinic for more interesting videos. You can follow me on TikTok, Instagram, and Facebook. Thank you for watching. See you in my next video.